Data Fusion and data proc. You're a DevOps engineer building data pipelines on GCP. Your team is collecting data from different sources, databases, APIs, logs, and they want to transform and analyze this data to power dashboards, ML models, and business insights. You're considering two powerful GCP services, Cloud Data Fusion and data proc. While both are data processing tools, they serve slightly different roles in your architecture. Cloud Data Fusion, Managed ETL Platform. Cloud Data Fusion is Google's fully managed visual data integration tool, built on CDAP, Cask Data Application Platform. Think of it like an ETL/ELT service where your data engineers or analysts can drag and drop pipeline components, no Spark code required. Use case. You need code-free ETL/ELT pipelines to move and transform data from sources like MySQL, pub/sub, GCS, BigQuery into a usable format. Basic Edition, limited features, no plugins or custom code, for simpler workflows. Enterprise Edition, full capability with secure data lineage, custom plugins, hybrid execution. How it works. 1. You design a pipeline visually. 2. Data Fusion compiles it into a Spark or Dataproc job under the hood. 3. It runs in a managed Dataproc cluster, which is automatically spun up and torn down. Limits and defaults. Default instance class, N1 standard 4. Pipeline run timeout, 1 hour by default. Parallelism limit, varies by plugin or cluster config. Plugins, Enterprise Edition supports custom plugins and secure connections. Key DevOps considerations. C/CD. Pipelines are versioned and can be exported/deployed using YAML or REST APIs. Monitoring, integrated with Stackdriver, cloud monitoring. IAM, fine-grained roles, viewer, developer, admin, can restrict pipeline editing versus execution. Dataproc, managed Apache Spark/Hadoop/Presto. Dataproc is GCP's managed cluster platform for big data frameworks, Spark, Hadoop, Hive, Presto, offering full control and flexibility for custom big data jobs. Use case. You need to run complex distributed processing, possibly with custom PySpark jobs, Hive queries, or mlib models, with full control over the environment. Standard clusters, manually configured and managed. Serverless Dataproc. Dataproc serverless, GCP handles autoscaling, spin-up, and resource management. Single node clusters, for lightweight dev/testing or orchestration. Limits and defaults. Default cluster size, 1 master, 2 workers. Preemptible worker nodes, optional to save costs. Auto-deletion, you can set idle timeouts to auto-delete idle clusters. Job types supported. 1. PySpark, Spark. 2. Hive, Pig. 3. Hadoop MapReduce. 4. Presto. Key DevOps considerations. C/CD, jobs can be triggered via Cloud Composer, Airflow, workflows, or even Cloud Functions. Infrastructure as code, Terraform support for cluster and job provisioning. Monitoring, logs via cloud logging, metrics available for autoscaling. Security, VPC service controls, Kerberos, encrypted disks, IAM roles. White check mark emoji. As a DevOps engineer, use Cloud Data Fusion if your team wants to abstract away Spark and build pipelines visually. Use Dataproc if your engineers are Spark/Hadoop savvy and need full control over how jobs run. For cost savings, look into Dataproc serverless or preemptible VMs. Integrate either with Cloud Composer for scheduling and orchestration, and monitor via cloud logging and monitoring. Let me know if you want Terraform examples or a pipeline YAML to deploy one of these. To load a 1 GB JSON file, analyze it, and split it into 10 smaller chunks, you can use Cloud Data Fusion for orchestration and transformation, and Dataproc for distributed processing. Here's a step-by-step DevOps-style narrative to get this done efficiently. Goal. Input. A 1 GB JSON file stored in Google Cloud Storage, GCS process, parse, transform/analyze, if needed, and split. Output. 10 smaller JSON or CSV chunks, each 100 megabytes or 1/10 of records. Option 1. Using Cloud Data Fusion, CDF, only, no code/low code EDL. When to choose? You want a visual ETL pipeline and don't need custom Spark logic. The file can be split by number of records or size using built-in plugins. Step by step. 1. Create a Cloud Data Fusion instance, Enterprise Edition if you're doing anything beyond basic. 2. Create a new pipeline. Source, GCS. Use GCS file plugin, set format to JSON. Parser. Use JSON parser plugin to convert the raw input into structured records. Optional. Add Wrangler or JavaScript transform plugin to do any analysis or filtering. Splitter. Use group by or batch aggregator to split into logical partitions. Sync. Use GCS sync plugin. Configure 10 separate outputs by A. Writing to different GCS folders. B. Or dynamically naming output files like part1.json, part10.json. 3. Run the pipeline. Cloud Data Fusion will convert this into a data proc job behind the scenes. Output will be 10 files written to your target GCS location POTA4. Verify output using gsutil-ls or GCP console. Option 2. Use DataProc plus PySpark, custom code, full control. When to choose? You want full control over how the JSON is parsed, analyzed, and split. You need to handle complex or nested JSON formats. Step by step. 1. Create a DataProc cluster, or use DataProc serverless for simplicity. Cloud DataProc clusters create JSON cluster region equals a central one single node enable component gateway. 2. Write your PySpark script, split_json.py. From PySpark.sql import Spark session. Spark equals Spark session.builder.appName split JSON. Get or create. Hash load 1 GB JSON from GCS. df equals spark.read.jsongs:/ your bucket / input / large_file.json. Hash optional analysis, for example, show schema, filter rows, compute stats df.print schema df.describe, show. Hash repartition into 10 parts. df.repartition 10. Write.mode overwrite. JSONGs:/ your bucket / output / split / 3. Submit the job. Cloud DataProc job submit PySpark split_json.py cluster equals JSON cluster region equals us central one. 4. Result. You'll find part 000 to part 0009 files in gs:/ your bucket / output / split /. Recommendation. Use Cloud Data Fusion if your team prefers a GUI-based pipeline, and the transformation is relatively simple. Use DataProc with PySpark if you want full programmatic control, flexible data transformation, or need to do advanced analysis.